Hello everyone, Mr. Minnick's my name, math is my game, and I'm kind of excited because today in my Algebra II classes, we're finally starting and going to complete one entire chapter from start to finish. There's, I believe, 9 or 10 sections in Chapter 4. We're going to be on Chapter 4 for probably the next 6 to 8 weeks of school. So here's the first section, Chapter 4, Section 1, the title. I'd write that down if I was taking notes. Quadratic functions and transformations. I would probably give it an alternative title. I would say probably vertex form of a quadratic function. That's probably what I'd title this section, but anyway, either way. Vertex form of a quadratic function, that's the big idea. That's the big takeaway that we're going to have from today's lesson. The objective, the goal is to be able to identify a quadratic function and to be able to graph a quadratic function. Common Core content standards, you don't need to write those down, but it's just a continuation of what we did in 2.6 and 2.7. If you think back to the last section from 2.7, well, a couple sections ago, when we looked at something like y equals the absolute value of x minus 2 and absolute value plus 5, the idea moving forward, the concepts that you should remember is how to identify the vertex from that. What would the vertex of that particular absolute value function end up having coordinates of? Anybody remember? The x coordinate is going to come from the parentheses, and the y coordinate is going to come from whatever's being added to the end. So what's the vertex of this thing going to be? Anybody think they got it? 2, 5, nice. Somebody brought their A game. Do you mind if I shout you out? Shout out to Tyler Griffith, 2, 5. And it's weird because it's x minus 2, and you might think it's negative 2, 5, but what we've been saying all along about that x coordinate of the vertex, it's the opposite of what you think. Remember all that stuff from last week, I hope? Because it's all going to come into play today. So here we go, vertex form. Vertex form of a parabola. What it looks like is this. Y equals little a times the quantity x minus little h, the quantity squared, plus k. That's vertex form. The coordinates of the vertex then, are going to be the coordinates of the vertex. The coordinates of the vertex are going to be h, comma, k. On an upcoming test or quiz, I'm going to ask you, what's h? And the answer I'd expect you to give me is it's the x coordinate of the vertex. I'll ask you, what's k? And the answer I'm looking for is k is the y coordinate of the vertex. That's supposed to be a colon, not an exclamation point. It's supposed to be a colon. There it is. So the coordinates of the vertex are h, comma, k. The A tells us I'm going to put in quotations the width of the graph. I'm going to put in quotations the width of the graph. There's more to it than just the width. Maybe we might remember if A is positive, the graph is going to open upward. If A is positive, the graph's going to open upward. So if A is greater than 0, that just means it's positive. Then the graph opens upward. What's the converse of that statement? If A is negative, then the graph opens downward. Perfect. Nice job. Awesome sauce. If A is negative, the graph opens downward. If A is negative, let's try that again. If A is negative, The graph opens, well, you get it, downward. Oh, I forgot a W. Downward. Downward. That's better. Okay. How's everybody doing up to this point, okay? What I'd like to do is I'd like to just look at a couple graphs of y equals x squared. We graphed this a while ago, and you need to be able to graph this with one hand tied behind your back. Not that anybody's going to do that in here, but you need to be able to graph this quickly, by memory, without looking. You need to realize, oh, well, this is going to go through these points. It's going to go through the origin. That's actually its vertex. It's going to go through the point 1, 1. It's going to go through the point 2, 4. It's going to go through the point 3, 9. Bam, 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 bam. Whoop. And then how can I get the second half of the graph? How can I get the other side? What mathematical property lets me graph the left side of that? Somebody said it. Starts with an S. It ends with an imetry. Symmetry, sure. Symmetry, the graph is symmetric. The graph is symmetric, so it's going to look the same on the left half as it does on the right half. So the graph's going to look like that. And there's this line, there's this vertical line. I didn't draw a very straight vertical line there, but you get the idea. There's this vertical line that goes through the vertex. There's this vertical line that goes through the vertex, and that vertical line's equation is x equals 0, and it has a special name. That's an axis around which the graph is symmetrical. And here's how mathematicians are. Mathematicians say, well, if it's an axis around which the graph is symmetrical, you know what we're going to call this thing? The axis of symmetry. We're going to call it the axis of symmetry. We're going to call it the axis of symmetry. The axis of symmetry is that vertical line that the graph is symmetric around. When you talk about it, you have to write its equation, and its equation is x equals 0. To be as clear as mud, this 0 right here is the same as this 0 right here. The x-coordinate of the vertex is where the equation for the axis of symmetry comes from. That's always going to be the case. Question? So there's a couple more things that we need to really build up, and we will. And I'm going to go to Desmos. I'm going to go to Desmos, and I'm going to graph this function x squared here, x squared. And what I want to do is I want to try to zoom in if we can. And I want everybody to see that this graph, see if I can write over top of this. This graph goes over 1 unit and up 1 unit. Can everybody see that? Goes over 1 and up 1. The reason the graph does that is because of the coefficient in front of x squared. What number is sitting in front of that x squared? 1. What I'm trying to tell you is that if there happens to be a 2 in front of that, if there happened to be a 2, if we had x squared with a 2 in front of it, we would still go over 1 unit, but guess how far up we would be going? 2. We would be going up 2. Now, if you don't believe me, let's clear all that junk off of there, and let's look at it. Let's look at it. What I'm trying to develop here is the idea of this A value, what all A does to the graph. Okay, so now I got a 2 out in front. So notice, again, I went over 1, and this time I went up 2 because of that 2 right there. Does that make sense? Now with the parent function says go over 2 and up 4. But let's see how far up I went if I go over 2. On this one, if I go over 2 units, 1, 2, how far up do I go? When I go over 2, how far up did I go? 8. Huh. Okay, that's kind of interesting, and we're gonna use that idea again in a minute. Everybody feeling okay so far? Good. Well, what happens? What happens if the a value equals 0? What if I put in 0 x squared? What do you think is going to happen? A straight line, a horizontal line actually, right? So we better go back and say something. When we talk about this vertex form, we better say a is not allowed to equal 0. That's important. That's what I call a restriction on the variable. A is not allowed to equal 0, because if it does, we don't have a parabola. We don't have a quadratic function. We have a horizontal line, and those are boring. I'm going to say one more thing about A before we move on. A tells us from the vertex, go over 1 and up/down A units. That's what the A value tells us. It tells us from the vertex we're going to go over 1 and either up or down A units. So it's kind of like a slope, but it's not exactly a slope. It'll determine how wide or how narrow the graph is, but it's not exactly a slope. Are there any questions, comments, concerns, short or long debates up to this point? Okay, so here's what's going to happen. They're going to have you graph some stuff that's not translated right or left or up or down or horizontally or vertically. They're going to have you graph some stuff that just has a different A value, like this one here in problem 1. And so I'll kind of walk through this on a fresh paper here and show you how I would approach this one. It's kind of cool, kind of the same way what they got going on. So we're going to graph y equals 1/2 x squared. Cut that out. Put it on a new page. Maybe. Edit, paste. There it is. Okay. So the first thing I like to do when I graph anything like this is I like to identify my vertex. I could rewrite this as 1/2 times x minus 0, the quantity squared, plus 0. So where's my vertex? 0, 0. My vertex is 0, 0. So there it is. There's my vertex. 0, 0. Now what's my A value? What's my A value? What is it? 1/2. So that means from the vertex, go over 1. And it's always going to be over 1. So from the vertex, I'm going to go over 1. I'm going to go over 1. And how far up or down? I heard an up 2. It's not going to be up 2. Let's see what we said about A. A says from the vertex, we go over 1 and up or down whatever A is, right? So in this case, our A value is 1/2. So when we go over 1, how far up or down are we going to go? We're going up just 1/2. Up just 1/2. Okay. Everybody good with that so far? Here's where it gets weird. Here's where people don't understand. If we were graphing the parent function, we're not, but if we were, we know that the parent function, y equals x squared, would go over 2 and up 4, right? But we're not graphing that one. We're only going to be going up half as high. We're still going to go over 2, but we're only going up half as high. So when we go over 2, how far up are we really going? Half of what we normally would. Half of 4, which is going to be 2. Okay. Similar idea with the parent function. If we went over 3, With the parent function, if we went over 3, we'd be going up 9. With the parent function, if we went over 3, we'd be going up 9, but we're not going to go up that high. We're only going to go up half that much. So we got to ask ourselves, what's half of 9? Half of 9? Bueller? 4 and 4.5? Okay. So when we go over 3, then we're going to go up 4.5. Go over 3, we're going to go up 4.5. And that's the way, I like it, that's the way, How do we feel about being able to graph something like that? All right. On Wednesday's quiz, you're going to have to graph 2 of those without a graphing calculator. I think most people are good with the vertex. I know most people are good with the vertex. I think most people are good with that first point after the vertex. It's that next point after that and the next point. So we'll practice a few more of these. So they're talking about reflections. They're talking about vertical stretches and shrinks and that kind of thing. So what they want us to graph now are a couple of translations. They want us to graph a couple of translations. So I'll go ahead and cut this. We'll put it on a new page. And we'll see what that one looks like. So again, the first place I like to start with one of these is the vertex. Maybe you know what the vertex is, maybe you don't. It's not exactly in vertex form, though. If I wrote this in vertex form, I would say that this equals the quantity of x minus something squared minus 5. The quantity of x minus what squared? I know you don't see the parentheses because they're not there, but what's in the parentheses? 0. So what's my vertex? 0, -5. So my vertex is 0, -5. Vertex, 0, -5. One thing I haven't been doing, I probably should, is I should sketch my axis of symmetry. I should sketch my axis of symmetry. Here it is. My axis of symmetry, I abbreviate AOS, it's x equals 0 in this case. So I got to find my A value. What's my A value here? My A value is it's not 0, it's the coefficient of x squared. What numbers sit in front of x squared? The 1. So that means from the vertex, I'm going to go over 1 and up how far? Over 1 and up 1. What this problem is really the same as is the parent function. It's just translated down 5, right? So from the vertex, I'd go over 2 and up 1, 2, 3, 4. And I'd go over 3 and up. There's 4, there's 5, there's 6, there's 7, there's 8, there's 9. Like that. And that's it. And I sketch the parabola like that. Make sure that when you do this, that you are sketching in the arms of the parabola, those smooth curves. My left arm of the parabola looks pretty bad, but you get the idea. Something I'm real big on is labeling these points. I plotted points, I didn't label anything. I might say the point P has the coordinates 1, -4. The point Q has the coordinates 2, -1. Okay, that's what I mean when I say label. To be clear, on an upcoming test or quiz, if I ask you to label points, that's what I mean by labels, okay? That's what I mean by a label. Simply putting a dot there, all you're doing is plotting it. There's a big difference between plotting and labeling. Are there any questions about anything we've seen so far? Any questions about graphing parabolas in vertex form so far? Okay, let's look at the next one. Let's look at the next one. Like putting these on a brand new page. Anybody think they know where the vertex is going to be on this one? 0. Nice, good. 4, 0. So there's my vertex. 4, 0. Axis of symmetry, remember, is this vertical line that goes through it. Wow, that was bad. Let's try that again. Axis of symmetry is a vertical line that goes through it. There's my axis of symmetry. What's the equation for that? X equals what? X equals, what would be X equals 4? X equals 4. Okay. What's my A value? My A value is 1. So once I got this vertex established, which I do, it's just going to be like the parent function. From there, I go over 1 up 1, over 2 up 1, 2, 3, 4, and over 3 and up 9. Just like that, and just like that. Boop, boop. The point would be 5, 1. Another point would be 6, 4. And another point would be 7, 9. There we go. Okay. Well, there's something when we graph these that I haven't talked about yet, that we talked about last week. Remember when we mentioned the domain? Remember when we mentioned the domain? That's all the x values that this function can take on. The domain. If we look along just this x-axis, what values of x would this function take on? What's the lowest and the highest ones? These little arrows up here kind of help us figure that out. Those arrows mean it goes to the left forever, and it goes to the right forever. So what's our domain? From positive infinity as low as, it goes farther than 0. It goes to the negative infinity too, right? So that's our domain. That's going to be our domain for just about everything we graph up until chapter 6. Our range is a little bit different. Our range, if we notice, I wanted that to be red. Change color markers here. Our range is a little bit different. Our range is what y values does this function take on? What y values does this function take on? And if I look at my y-axis, that thing doesn't go below 0. So my range isn't going to go below 0. My range is going to go from 0 up to infinity. Okay. Questions, comments, concerns, short debates, long debates? Tonight's homework, you're going to have 6 graphs, basically. 6 graphs, and then they're going to ask you some other questions about some other facets of this. So we need to talk about a couple of words. We need to talk about minimum, minimum, and maximum. Minimums and maximums occur at the vertex. If we're talking about the minimum, if we're talking about the maximum, see if it likes my ampersand. Yep. The minimum and the maximum, they occur at the vertex. They occur at the vertex. But sometimes you're going to be asked, what's the minimum value? What's the minimum? What's the minimum? What's the minimum? Come on. Or the maximum. Or the maximum value. What's the minimum value? What's the maximum value? And to be real clear about this, the minimum value, the maximum value, both of these are the same thing. It's the y coordinate. It's the y coordinate of the vertex. It's the y coordinate of the vertex. I know that's a real subtle thing, but it is a thing. So if you're asked, what's the minimum value, what's the maximum value, it's the y coordinate of the vertex. And that's going to show up in your range also. That's going to show up in your range. So the minimum value, the maximum value, What those are is simply the y-coordinate of the vertex. If you're asked where does the minimum occur or where does the maximum occur, it's going to occur at the vertex, but specifically the minimum value is just the y-coordinate, or specifically just the maximum value is the y-coordinate. I think we better analyze one of these graphs. Okay. So suppose we had a graph that looked like this. Whoop, whoop, whoop. Shoo, shoo. Here's my vertex at the point 4,8. Here's some point next to my vertex. Ooh, yeah, let me just leave it like that. Here's some point over here that's going to be 6, 7. Ooh, this is tricky. So the maximum or minimum, let's first of all just determine which this has. Does this have a maximum or a minimum? How'd you know it has a maximum? Because the a is less than 0, so the graph opens down. I guess it's common sense, right? I hope that everybody understands that that's a maximum. So the graph has a maximum, so we'll say the maximum occurs where? Where's the maximum occur? 4,8. The maximum occurs at 4,8. But what if you're asked this question? What if you're asked, what is the maximum value of this function? Then your answer is going to be a little different. What's the maximum value of this function? Somebody said it? It's 8. Good. The maximum value of this function is 8. Does that make sense about the maximum and the minimum values? Awesome. Well, I don't know if this is part of the objective today, but I think it's a good exercise. Let's see if we can find our A value. Let's see if we can find our A value. One thing we know about our A value here for sure is that it's what? Because the graph opens downward. It's negative. I wonder if there's anything we could use. If there's anything we could use to calculate our A value. Do we know an H and a K and an X and a Y? I don't know if you're picking up what I'm putting down here. H is this 4, right? And K is this 8, right? What about X and Y? Do we know those? They give us this other point. 6 is the X, and 7 is this Y value. So we could make a substitution. So let's make some substitutions. So Y, 7, equals A, I don't know what A is, I'm solving for that, times X, 6, minus H, 4, the quantity squared plus K, so plus 7, plus 8, okay. 6 minus 4 is 2, so 7 equals A times 2 squared plus 8. If I minus 8 from both sides, I get negative 1 equals 2 squared is 4, so negative 1 equals 4A. And so A would equal negative 1 divided by 4. So I could calculate the A if I had to, if I knew some other point. I could calculate my A if I knew some other point. What do we think so far? Does this stuff make sense? Does it kind of tie into what we did last week? Maybe we should try to write the graph. Maybe we should try to write the graph. Write the equation. Write the equation of the shown graph. So we'll look at a graph and we'll try to write the equation of this thing. Bum, 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 bum. Whoop, whoop. Here's my vertex. That's -5, -7. Here's the point P at -4, -4, -4, -4. Cool. So my answer to this is going to have to start off with y equals something times x something something squared something something. Let's see. Maybe we'll wait a minute on the a value. What's going to go in the parentheses? You might think a -5 goes into parentheses, but what's in parentheses is the opposite of what you think. So it's not just a 5, but a x plus or -5. X plus 5 in parentheses, right? What goes after the parentheses? A -7, -7. And then we need to find our a value. What the heck is a? Remember what the a told us. The a told us from the vertex. From the vertex, we always go over 1 and up a units. Okay, so what's my a value going to be then? Should be able to tell from the given point. The a value here would be 3. Good, the a value is 3. So that's going to hang out front here, and that's it. Questions about that one? Comments about that one? Concerns about that one? Short debates about that one? Okay. Suppose we had y equals -2/3 times the quantity x plus 4, the quantity squared minus 6. They're going to ask you for the vertex. They're going to ask you for the axis of symmetry. They're going to ask you for the domain. They're going to ask you for the range. They're going to ask you for the min or max value. And you should be able to answer all those without doing any work. What's the vertex of this thing? The vertex -4, -6. Axis of symmetry, remember that's a vertical line, so vertical lines are defined by equations that say x equals something. X equals what? Not 4. X equals, if you forgot this, remember that this and this will always be the same. So x equals -4. So what about our domain? The domain. There's no restrictions on the x values, so negative to positive infinity. What about the range? That's a tricky one. You might want to sketch a picture. Sometimes a picture's worth 1,000 words. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. The vertex is going to be over here. Which way does this graph open, up or down? The graph opens downward, so that's going to help us with our range here. What's our range going to be on this? So it's tricky. Remember, the range goes from the smallest number to the biggest number. -6 is going to be part of it. Is that the smallest number, or is that the biggest number? That -6 is actually the biggest number. What's the smallest the range is going to get down to? -infinity. So we'll say -infinity to -6, parenthesis bracket like that. And what about our minimum or maximum value? What's that going to be? Somebody said it. -6. Is that a min or a max? Is that a min or a max? Looks like a max, right? Okay. How do we feel about identifying parts of the graphs without actually graphing? Should we try another one of those, or you got the hang of those? Another one of those? Okay. Hey, there's one right here. Cool. So they want to know what the vertex of this one is. So what's our vertex? 4, -2. And our axis of symmetry, we can't just say -4 or 4 for that matter. We got to say that x equals. So it's got to be x equals. Is it going to be 4 or -4? It's x equals 4. Okay. And our maximum or min value, is it a max or a min? It is a min. And our min value would be what? Min value would be not 4, -2. If we sketch a quick graph, 1, 2, 3, 4, down 2, quick sketch of this thing, the graph's going to open like that. So, and it does have a min value in our domain. Our domain's always going to be the same, this negative to positive infinity. And what about our range here? What about our range here? From where to where? Goes as high as infinity and as low as our minimum value of -2. So -2 to infinity. Okay. So being able to identify all these parts is probably equally as important as actually being able to graph it. Okay. So I think there's one more problem they want us to graph maybe. Yeah, let's go ahead and graph this next one. And then we'll look at a multiple choice, and then that'll be it. And then that'll be it. So here we go. Let's see if we can graph this one. Remember, when you go to graph it, you always got to start with the vertex. Number one, first step, always find the vertex. So what's our vertex going to be here? 1, 3. It's going to put us in quadrant 1. We'll label that. There's our vertex, 1, 3. How did I know to put that label above that point? Because the graph's going to open down. How do we know the graph's going to open down? Because of the -2. That's my a value. My a is -2. So from the vertex, when I go over 1, I want to go down 2. Bam. Bam. If you were able to just graph that much, if you were able to graph just that much, that's going to get you 4 out of 5 on one of my test questions. And for some people, that's good enough. But what if you wanted to get all 5 out of 5? What if you wanted to know when you go over 2 units, how far up or down are we going to go? So then we got to think back to the parent function. The parent function says we'd go over 2 and up 4. But what we're doing is we're multiplying that 4 by -2. So what we would be doing is going over 2 units, and then what? What's 4 times -2? -8. So when we go over 2 units, we'd be going down 8. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, like that. And like that. Okay. Whoop, whoop. So my point P would be the point 2, 1. My point Q would be the point 3, -5. Completing the graph, it's always a good idea to sketch in the axis of symmetry. Axis of symmetry, x equals 1 in this case. How do we feel about graphing these things? All right? Think you got a pretty good shot with tonight's homework? Good. Well, I'm going to give a shout out to the future Mr. Minnick. I hope you have a great Monday. Anybody watching this back at home, shout out to you. Shout out to Tyler, brought his A game in my second period class here. Nice job. Anybody else want to give a shout out to anybody else? Well, that's it. See you next time.
Good.